Hello, algebraic reasoning. Today we're going to be talking about exponents, and we're going to start today by talking about the zero and the negative exponents. So, first things first, let's talk about what exponents mean. So, in the first example, you see 2 to the 4th here, or given right here. And what 2 to the 4th means is 2 times 2 times 2 times 2 4 times, which would give you 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. And so what do exponents mean? It just means you multiply what's called the base. This 2 is the base. You multiply it by itself as many times as you have the exponent. So because the exponent is 4, we can see that we multiply 2 by itself 4 times. Okay? Do not confuse this with 2 times 4, which is 8, right? It means 2 times itself 4 times, okay? So 2 cubed would mean 2 times 2 times 2, which would be, we said 8. 2 to the second power would be 2 times 2, which is 4. 2 to the first would just be 2 by itself. And so there's a question of what is 2 to the 0 then? 2 times what? Well, let's look over on the other side. So let's start with, what is 2 to the negative 1? Well, whenever the exponent is negative, this means that you're actually doing what's called the reciprocal. So you're actually going to flip it and you're going to say 1 over 2. So 2 to the negative 2 would just mean means the same thing as 1 over 2 squared, or 1 to the 4th. Okay, so we know that this value here is going to be 1/2, and the one next to it would be one below is 1/4. So what do we realize that we're doing? Well, what is the situation going on from 16 to 8, from 8 to 4, from 4 to 2, and then here from 1/2 to 1/4? Well, we can see that what's actually transpiring is we're dividing by 2 or multiplying by 1/2. So what is 2 times a half? So what is 2 times a half? That is clearly going to be 1. And so 2 to the 0 is 1. And so this is a very important property, which is that any value other than 0 raised to the 0 power is 1. So if I give you 4 to the 0, that's 1. If I give you the quantity negative 4 to the 0, that is still 1. If I give you 1/2 to the 0, that is still 1. Okay? Where this gets a little interesting is if you see something like this, negative 3 to the 0. And so when you see this, you have to follow Pemdas, which is that we have to deal with this part here first. So 3 to the 0 is 1, and then we have a negative in front. So this is actually equal to negative 1. Notice that contrasts with this value here, which is just 1. So when we have the parentheses around it is just 1. When we have the 1 on the outside, it becomes, or the negative sign on the outside without parentheses, then it becomes negative 1. And this really does matter, because a lot of y'all type things into the calculator, and if you're not paying very close attention, you will type it in incorrectly. Okay, so let's try the next question, which is, it says right here, what happens when you decrease the exponent by 1? What do you think 5 to the negative 2 is? So let's think about this for a second. So we just finished saying that with 2, we were just dividing by 2. So with 5, let's say we start with 5, which is 5 to the 1, which is clearly 5. So then 5 to the 0 is 1. Either because we just finished saying that anything raised to the 0 power except for 0, and I'll talk more about this later on, is going to be 1. So then what would 5 to the negative 1 be? Well, notice if here we're just dividing by 2 to drop it each time, then here clearly it would be the same thing, right? Because you have 1 less 5. So what's 1 divided by 5? 1/5. So then what would 5 to the negative 2 be? Well, this would be 1 over 5 squared, or simply 1 over 25. Okay, so there we have that. All right, so let's look at the next question. So let me do this. Yeah, Grace, fine. says consider 3 squared, 3 cubed, 3 squared, and 3 to the 1. So I hope everyone realizes that 3 cubed is 3 times 3 times 3, which is 27. That 3 squared, I should write these out. That 3 squared is 3 times 3, which is 9. And that 3 to the first is just 3. Notice I don't even know what the question's asking me. I really don't. I'm just writing down what each of these are. Decreasing by the exponents by 1 is the same as dividing by 3, or the base, right? To be more universal, it's the base, right? The base here is 2, so we were dividing by 2. The base here is 3, so we're dividing by 3. The base here was 5, so we're so we're dividing 3 by 5. Okay, so that's what's going on there. If you continue the pattern, then again, 3 to the 0, we know it's going to become 1. And then 3 to the negative 1 is 1 over 3. So the other property that we want to stress is that when it's a negative, we do the reciprocal, we put it in the denominator. Okay, so there's the first page. Let's look at the next one. So we've kind of already talked about this, but we said a to the 0, and notice it says for every non-zero. This is important. It's not actually 100% true, but for most of the cases it will be. Non-zero numbers, a to the 0 is 1. So here are examples. I gave you some earlier. 4 to the 0 is 1. Negative 3 to the 0 is 1. 3.14 to the 0 is 1. Pi to the 0 is 1. 3.14 rounds to pi, but it's not actually pi. But even pi would be 1. Okay, and then we also talked about this already. What are negative exponents? Well, we said negative, you just put the number in the denominator. So 7 to the negative 3, same thing as 1 over 7 to the third. Parentheses negative 5 to the negative 2, same thing as 1 over negative 5 squared. Okay? Let's see. Let's read it in the vernacular of the text. Just flip the power over the division bar to make it positive. The only thing that changes is the sign is the exponent. Base number stays the same. So what they're trying to say here is if this is negative, when you flip it, that becomes positive. If this is negative, when you flip it, that becomes positive. Cool. So let's solve the ones on the bottom. So what is 6 to the negative 2? I'm not concerned with actually solving for 6 squared, okay? Or 6 to the negative 2. Just to rewrite it. So this we said is you basically flip it and put it as an exponent. So this would be 1 over 6 squared. If I was wanted to solve, it's not hard. It's 1 over 36. Why? Because 6 times 6 is 36. Again, want to stress, 1 over 6 squared does not mean 6 times 2, which is 12. It means 6 times 6. I stress this because this is the common mistake that students make. What is the quantity negative 9.3 raised to the 0? Well, we said anything other than 0 raised to the 0 power is 1. Next one. What is negative 4 to the negative 2? I'm going to rewrite that. That's negative 4 to the negative 2. Well, we said we're going to do the reciprocal. So the negative actually stays on the outside, and we're going to do 4 squared. So it's negative 1 over 4 squared. And if you wanted to break this down, this is negative 1 over 16, because 4 times 4 is 16. And D, notice in D it's in parentheses, so this one, which I'm going to start, let me do it a different color. This one, I'll do yellow, is in parentheses. So now we're going to take it all to the bottom. We're going to square it. But notice here, because the negative 4 is in parentheses, we're going to do negative 4 times negative 4, which is 1 over 16. So this is a very important distinction. This is a very common place that people will make mistakes and miss the questions. Notice in C the answer comes out as a negative, whereas in D it comes out as a positive. You have to watch the parentheses. It really matters. Okay. Cool. All right, let's move on. So what is the simplified version of each of the following? So let's tackle it. So 3, a to the negative 2. We said when it's negative, it goes to the bottom. Change the exponent to positive, times b cubed. And so if we could put this all together, remember any number is is the same number divided by 1. So 3 is the same thing as 3 over 1. And b cubed is the same thing as b cubed over 1. And so when we multiply this out, we get 3b cubed over a squared. The next one's actually really interesting. We said when it's the negative, we flip the position, but we've only seen it when it's in the numerator. But the truth is when it's in the denominator, it flips back to the numerator. So this is actually the same thing as saying x to the 6. Notice I just reciprocaled. I just flipped it to the numerator. Okay, let's look at the last one. 6a to the negative 1. So I'm actually going to do this. I'm going to rewrite this as 6 to the a to the negative 1, c to the negative 3. And so for the d to the 0 on the bottom, I'm actually going to rewrite this as a multiplication. And this is where it's useful to realize, it's a little cluttered. It's useful to realize that dividing is actually just multiplying by the fraction. So like dividing by 2 is the same thing as multiplying by 1 over 2. Dividing by 3 is the same thing as multiplying by 1 over 3. And let me rewrite this so it's a little cleaner looking. And it's not, I guess it's not that much better looking, but it's a little better. Okay, so we're going to clean up each of these. So a to the negative 1 is just the same thing as 1 over a. C to the negative 3 is the same thing as 1 over c cubed. Remember, when it's negative, you just flip the position. So if it's in the numerator, it's the denominator. If it's in the denominator, it's in the numerator. And the last one is actually really interesting because we know anything, and we're going to assume here, it doesn't state it, but we're going to assume that d does not equal 0. And so this is going to be, we said anything other than 0 is going to become 1. So we're as such, clean it up. Remember, 6 is the same thing as 6 over 1, so this is just 6 over ac cubed as such. And you don't have to do this every single time. If you want to look at this and you're just like, okay, well, that means a goes to the bottom. The negative exponent means c goes to the bottom. And then d to the 0 is 1, just write that as such. That's perfectly legit as well. Okay. Let's move on. Example 3, what is the value of 2a squared b to the 4th? So, and now what they're doing to spice it up, they're actually giving us values for a and b. But what I'm going to actually do is I'm first going to rewrite this in a simplified version, which just means that the negative value is going to go to the denominator. Then I'm going to just substitute in the values. So b is 1, so 1 to the 4th. And a is negative 2, but it is the quantity that's being squared. And this is the distinction that's very important to realize. So that negative 2 squared is not written as negative 2 squared, which would be negative 1. And I have to stress, I can't keep stressing this enough, because if you type that in the calculator as negative 2 squared, the calculator will give you negative 4. It will not give you the desired 4 value that you want. You have to put it in parentheses because you're following Pemdas. Speaking of Pemdas, if we solve this, we will follow Pemdas, which means I have to do exponents first, which means I have to play with 1 to the 4th, which is just 1, because 1 to the 4th is 1 times 1 times 1 times 1. If you said 4, it's because you're not thinking clearly about it. You got to stop yourself from thinking that way. It just means 1 times 1 times 1 times 1. So 2 times 1 is just 2. So we'll have 2 on the top. On the bottom, we have the quantity negative 2 squared, which means negative 2 times negative 2, which is 4. And then we will simplify this down to 1 over 2. Okay? There we have it. Okay. And last but not least, example 4. It's always nice to do a word problem. Population of birds doubles 8 years. The expression 64 times 2 to the t models a population of 6,400 birds after t periods of 8 years. I want to stress that when you look at this, this is, if you recall from Algebra 1, this is called a geometric. And you see this in your future math courses as well. I just want to bring your attention to it. This is a geometric sequence. And geometric sequences just means that you just keep multiplying to get to the next term. Okay. In any case, It says evaluate the expression for t equals 0 and t equals -2. Describe what it means. So if it says evaluate, we're just going to plug it in. So we're going to do 6,400 times t. Now, notice t is 0, so we're going to put in 0 here. And when I solve this, I'm still following Pemdas, right? In Pemdas, I've said Pemdas a lot today, but I haven't written it down. Let me write it down. Pemdas. And what Pemdas says is they got to do exponents before you multiply. So I got to do 2 to the 0, which we said is 1. 1 times 6,400 is 6,400. And then we'll do it again for the other one, which is going to be 6,400 times, now they're saying -2. When it's negative, it means you multiply by the reciprocal. So this is 1 over 2 squared. And if you're seeing this, you don't have to do it like I'm doing, where I'm going step by step. You can jump to it. So it's 6,400 times 1/4, which is 1,600. Okay, now the interesting part of this whole thing is that it asks us at the end, it says, describe what each value represents. So what is the first 6,400? Well, if t is 0, this means where the population begins. So what about the 1,600? What does this mean? This is the population. Now, if it's negative, it means it's 2 years prior, right? 2 years before. And if you're thinking about this and you're like, yeah, that makes sense. It does make sense, except this question is very tricky. It says every 8 years. So it's not actually 2 years before. It's actually 2 times 8, or 16 years before. And that's where this question is a very high caliber sort of question. So, but it's important for y'all to get exposed to that. Okay, so this was our gentle introduction to exponents. I hope this makes sense. Stick around. The examples are going to get a little bit wilder, but if you just keep at it, you'll do fine. All right, guys. See you all in the next video.